practice test over Unit 2, logarithms. Use your paper as you work through this to show your work, describe how you found the answer, take notes, ask questions, because you can use this with your notes on your test. We're going to take 2 days to cover the review, and you can reach out if you have any questions before you take the test. All right, question number 1 says we're given x equals 5 to the x. We want to describe, or we're asked to describe the transformation of the function to get this graph, g of x equals 5 to the x minus 9 plus 2. So our parent function is here. It's an exponential function. We're raising to the power of x. So if you think about this, when we made a table of values, starting with 0, x and y values, let x be 0, 5 to the 0 power is 1. So when x is 0, y is 1, that is where it's going to cross the y-axis. Okay, and then it's going to go up incrementally because this number is going to show growth is greater than 1. Now if we subtract 9 from the exponent, what happens to that graph? And if we add 2 to the end of the function, what happens to the graph? So there are a couple of approaches here. You can graph the original function, look at it, note some important features, and then graph the transformation or the new function, and then describe that mathematically. You should have transformation rules written down in your notes, and there's an anchor chart at your desk to refer to. So let's just use this anchor chart. So what is happening to this original function? We're subtracting 9 from the x. Okay, so it's going to have to be with the x. We're subtracting a number c. So that's going to be a horizontal translation to the right, c units. Okay, so we're adding c to our x values. Okay. So you can say horizontal translation. I'm just going to say moves to the right. How many units? 9. And now we're looking at that plus 2 at the end. Now this is just adding a number at the end of the function, the original function. So let's look at our rules. It's going to be this first one. We're adding a number. That's going to be a vertical translation up d units. Okay, so that number is 2. We're going to move it up 2 units. Again, you can graph that in Desmos, and I'll show you what that looks like. 2 approaches to this. All right, you can see the original function f of x equals 5 to the x. Again, it's crossing at the y-axis at 0, 1, just like we said, because any number to the 0 power is 1. And it's going to go up incrementally. This number, we added 7 to the end. And I can see that question number 2, adding 7. I don't have that turned on. Let me turn it on. Okay, that's going to move it up 7 units. So it's actually going to cross because it started at 0, 1. Add 7 to 1. It's going to go up to 8. All right, so going back to the question, what is the y-intercept of the following function? So if we started here at 0, 1, and we went up, that's the y, 7 units. We're adding 7 units to 1. Okay, so the y-intercept is going to be 0, 8. Question number 3, we're asked to solve for x in this equation. Log base 7, 54 equals log base 7x plus log base 7, 9. Round to the nearest 1,000. Okay, so let's write the question down so we can show our work. log base 754 equals log base 7x plus log base 7, 9. Okay, think about your exponent rules and the inverse of that, specifically for this, the log function rules. All right, so we have the same base. We've got log base 7 throughout. So that's the good news. Okay, there's nothing to combine here. We don't want to pull anything apart. We want to solve. All right, so now we have the same base. We're adding, so we can write this as log 7, 9 times x, 9x, equals log base 7, 54. Okay, again, we have the same log base 7. Okay, so we can scratch that out or we can cross it out. It's like looking at the exponents in an exponential equation, setting those equal. Okay, so we have, I'm going to switch sides here. 9x is equal to 54. Divide both sides by 9. X is equal to 6. All right, and you can check your answer, box it in, show your work, keep your notes. All right, let's move on to question number 3. That was question number 3. Go ahead and put that down. X is equal to 6. Question number 4, solve for x in the following equation. So again, let's write that down. Maybe I have enough room here. Let me try. Okay. 2 plus log base 5, 4 equals log base 5x. Okay, we have log base 5. Okay, so now let's start putting some things together. Okay, so we start by writing the equation, and I switch sides so I could have that variable on the left. That's just the way I like to start. All right, so I have log base 5 here, log base 5 here. I just have a number here. So I'm asking myself, can I rewrite 2 as a logarithm with base 5? So think of your log rules. All right, our exponent on the side of the equal all by itself is always going to be our exponent. Okay, we have a log base 5. So this is our base. So if I put 5 squared here, okay, that's going to equal the exponent. So I can rewrite 2 as, use our base, log base 5, 5 squared, because I'm trying to match that exponent. Now I can rewrite 2 as log base 5, 5 squared, and 5 squared is 25. So I'm going to rewrite that right here. All right, I still have log base 5x on the left. Now I have log base 5, 25, plus log base 5, 4. When you're adding logs, you multiply these numbers because I have the same base. So 25 times 4 is 100. Now we can cross out log base 5. X is equal to 100. Box that answer in. All right, you might take a while to look at that. You need some review with the logarithm rules. You can come see me for help. You can ask a partner. Let me know if you have any questions there. All right, let's move down to question number 5. Evaluate using the change of base formula and round your answer to the nearest thousand. We're looking at log base 5, 13. So the change of base formula, let's write this down on our paper, use it for notes. Change of base formula says log base A, B. We're going to take that top number, the number that's at the top, put it at the top of a fraction, and you can choose any base that you want. Just make sure it's the same number. Okay, so log base B goes on the top, log base A, not base, log B goes on the top, log A goes on the bottom, and then any base. So I'm going to choose the common logs, log base 10, which we can just write as log 13 over log 5. Again, this goes on the top, this goes on the bottom. Use the same base. So I'm using base 10 here, and over here I'm using the notation ln for base E, Euler's number. So I have ln 13 over ln 15. And if you put either of these in your calculator, you're going to get this number. And we're asked to round it to the nearest, let me go back and double check. Round to the nearest thousandth. Okay, so let's round carefully. Tenths, hundredths, thousandths. So let's look up at the next number. 6 is going to add 1 to the 3. So it's going to be approximately 1.594 for 1 and 594 thousandths. Question number 6, you're asked to evaluate and round to the nearest thousandth log base 5, 2 plus log base 5, 4. All right, so let's write that down. Log base 5, 2 plus log base 5, 4. Now you can put these in your calculator and you can add them together. Anytime you put this in, it's going to round a little bit. So what I like to do is use my product property for logs. When you're adding logs with the same base, you can multiply the 4 and the 2. 4 times 2 is 8. So this turns into log base 5, 8. Put this into your calculator. And what that means is 5 to what power is 1.8. And you're going to get approximately 1.292 if you round it to the nearest thousand. Log base 5, 8 is approximately 1.292. All right, let's look at question number 7. Question number 7 is a word problem. In 2001, the population in Niblett, North Carolina was 950 people. If the population is increasing at a rate of 2% per year, as modeled by this formula, n equals n sub 0 times 1 plus r to the t, predict the population in 2024. All right, so we have the formula. N sub 0 is our ground zero, is our starting point. Okay, this is going to be our total amount. So let's take what we've got. We start with 950 people. Okay, let me write that here. So 950 is our starting amount. Our percentage is 2%, and we bring that decimal 2 places to the left. Add that to 1, and then we're going to raise it to the time, the number of years. All right, so we're going from 2001 to 2024. Subtract 2001 from 2024. This time period is going to be 23 years. Okay, so that's what goes here. We have our equation or our formula set up, so plug that into Desmos. We picked out all the pieces. Calculate that, and if I did this right, it should be approximately 1,498. I'm just going to do a double check and see if that's a reasonable answer. From 950 in 23 years, growing at 2%, it's 1,498. All right, move to question number 8. Let's read the question. All right, now this time we're looking at bacteria growing in a petri dish. So the growth of bacteria in a petri dish can be modeled by P equals 425 e to the kt, where t is the time in hours. This time it's not days, it's not years, it's hours. Okay, the petri dish contains 580 bacteria, in 6 hours. So this is our final amount. Okay, so that's going to be this number right here, our final amount. So 580, let me write all that down. All right, so we have P, let me write the formula down again, equals 425 e to the kt. Okay, we're given the total amount, 580, after 6 hours, equals to, the initial amount is 425, multiply that by e, and we're going to raise that to the k times t, and time is 6, so I'm going to go ahead and put 6 times k, write it this way. All right, now we need to solve for k, and it is an exponent, so we need to isolate this part right here. So let's divide both sides by 425. I'm going to save my math for the end, so I'm not rounding anything off until the very end. I'll put everything in the calculator. All right, so this is 1. So I have on the right-hand side, I've got e to the 6k equals, on the left-hand side, I've got 580 over 425. Put that in parentheses. All right, now if I look at this, in order to simplify this, I need to take the natural log of both sides. I'm using the natural log because I have e. So I'm going to say ln of e to the 6k, and then ln of 580 over 425. Okay, now when I take the natural log of e, this is going to go away. Pull that 6k out. It's going to be left alone by itself. This is going to cancel out the e, natural log of e. All right, on the left-hand side, we have ln of 580 over 425. So I'm going to, again, save this for my calculator. Solving for k, so the last step is to divide all of this by, I'm going to put that over 6, use that as my division symbol. So putting that into the calculator, I think I come out with, and I may, and do this again, check my work, approximately 0.052 for K. Moving down to question number 9, it says John deposited $425 into an account that earned 4.5% compounded monthly. Assume no other deposits or withdrawals. How much will be in his account in 12 years? And here's your hint, here's your formula. A equals P times 1 plus R over N times N times T. Okay, and N is 12. So let's put 12 here. T is also 12, so it's going to be 12 times 12 is our exponent. 12 is our number. Put our rate up here. Let's plug all that in. Okay, our rate is 4.5. So our total amount is 425 times 1 plus 0.045 divided by 12. All of that raised to the 12 times 12, which is 144. N is equal to 12, T is equal to 12. All right, now let's use our calculator to do the work. All right, so I put these numbers into Desmos. Here's our initial amount times 1 plus our percentage rate is 0.045. Number of times we're compounding is 12. Okay, we're going to raise all of that to the number of times 12 times the number of time in years, and that's also 12. 12 times 12 is 144. And we get 728.56. And our answer, we're going to drop that 6709935 and get $728.56. All right, again, double check my work. Let me know if there are any questions, if I made any mistakes, but this is the way that you solve this. $728.56. Okay, let's move down to question number 10. Question number 10 asks us to expand log base 5 4x squared over y cubed. Let's use our logarithm rules and let's pull that apart. So we have log base 5 of 4x squared. Okay, subtract. Division means go back to subtraction. Log base 5 y cubed, y to the third power. That is y to the third power. I didn't lift it way high, but that's what it is. Okay, so we've pulled it apart. What else can we do? Okay, look at that for a minute. Is there anything else that we can do? All right, I know we worked this in class, so double check this. Now, this is all one piece, but we're only squaring the x. So when I take log base 5 of 4x squared, I can bring that 2 out to the front, and I can bring this 3 out to the front. Okay, 2 log base 5 4x minus 3 log base 5 y. All right, question number 11. And this is where we left off. If f of x equals log 6x and g of x equals log 13 minus x, what is the value of f of g of 4? So this is a combination of functions. We're going to start from the inside out. So I'm going to start simplifying g of 4. So I'm going to look only at function g. I'm going to substitute in for x in this part of the equation. I'm going to substitute in 4. So 4 goes in for x. 13 minus 4 is 9. So this becomes log base 10. This is a common log. So this is log of 9. Now I'm going to take log of 9 right here and plug it into function f. So here's function f. Function, everywhere there's an x, I'm going to replace it with log 9. So this is log of 6. So I just wrote log of 6 times log of 9. Okay, put that in your calculator. Okay, let's put that into Desmos and see what we get. All right, if I did this correct, log 6 times log 9, all of that inside parentheses, it's approximately 0.758 if we round it to the nearest thousand. All right, let's take out question number 12. We're not going to have a question like this on the test. It's going to take us too long. I don't want to keep going, beating a dead horse. Let's get what we know, and let's take out question number 12. We're not going to go from table to log function right now. All right, so that's it for day 1, and I'll put up day 2 a little bit later.